Now I want to talk about another important article which is called Hierarchical Losses and New Resources for Fine-Grained Entity Typing and Linking. This article in 2018. And the motivation is that extraction from raw text to a knowledge base of entities and fine-grained types is often cast as prediction into a flat set of entity and type labels, neglecting the rich hierarchies over types and entities contained in curated ontologies. Previous attempts to incorporate the hierarchical structure have yielded a little benefit and are restricted to shallow ontologies. So we know that, for example, in UMLS we have rich hierarchical structure over types, and so we can take advantage of that. But many of the algorithms really neglect this important fact. So the idea of this paper is that new methods, this paper presents new methods using real and complex bilinear mappings for integrating hierarchical information, yielding substantial improvement over fact predictions in entity linking and fine-grained entity typing, and achieving new state-of-the-art results for end-to-end models on the benchmark figure dataset. They also present two new human annotated datasets containing wide and deep hierarchies, which we will release to the community to encourage further research in this direction. MED mentions a collection of PubMed abstracts, and TypeNet, which aligns Freebase. This is an important knowledge graph with the WordNet hierarchy to obtain nearly 2K entity types. But entity types of UMLS are not big, but the number of concepts of UMLS is huge, millions of concepts. So the data set that they usually use, people in the literature, is that this MED mentions, as you have seen in the previous videos. So for mention encoder, their model converts each mention, for example, Barack Obama, into a d-dimensional vector, and so this vector is used to classify the type or entity of the mention. So you see in this figure 1, the model concatenates the average word embeddings of the mentioned string with the output of a convolutional neural networks. So we do max pool, and then we concatenate it with the mean representation, and then we use it for classification. So for sentence representation. And each sentence is made up of S tokens, which are mapped into a d-dimensional word embeddings. Because sentences may contain mentions of more than one entity, we explicitly encode a distinguished mention in the text using position embeddings. We also, concatenate the position as well. So each word embeddings is concatenated with a d-dimensional learned position embeddings, encoding the token's relative distance to the target entity. The embedded sequence is then fed into context encoder. The context encoder is a single layer CNN followed by 10 edge nonlinearity to produce C. And then the outputs are max pooled because we need a final context embedding. So finally, after this layer, we give it to this nonlinearity, and the mention is now represented by this one. So for the training, for mention level typing, we have two types of typing: mention level typing and entity level typing. For mention level typing, it's treated as a multi-label prediction. So given a sentence M of F, this is your sentence, we compute a score for each type set T. So for each type set T, we have a score. Y is a score. So Tj is the embedding of J's type in T, and Yj is the corresponding score. And then we just use a multi-label binary cross-entropy objective. But this is for type of dimension. So in the absence of mention level annotations, we instead must rely on distance supervision to. When we say distance supervision in this context of natural language processing, usually we mean, for example, in entity linking, we mean mapping or even relation extraction. We map it to something that we know, such as a knowledge base. But this problem, although it's very fruitful, very beautiful, very easy, but it has a problem, which the problem is it becomes noisy. All labels are noisy. So you have invented a new problem. So it's not a smart idea. And so for entity level typing, this is the I've mentioned, and for each of the sentence K, each of the K sentence vectors, and so this is a sentence which represents that mention. Each of the K sentence vectors is used to compute a score for each type. So for each type, we have a score. And T sub j is the embedding for the J's type. And the final bag predictions are obtained using element-wise log sum, pooling across, because we have K logit vectors in the bag to produce entity level logits Y. And then we use these final bag level predictions to optimize a multi-level binary cross-entropy objective. This is a multi-label binary cross-entropy loss. And you see in this appendix, we see that we accounted the generation details. In articles, they usually they map those UMLS into TF-IDF. It's a very simple task, and you see it in many articles. So the final prediction at test time, E hat, the final prediction of what entity is good, is the maximally similar entity to the mention. So you use this similarity between mention and entity, and also the sentence representation and entity type. So we care about type, we care about mention, we augment all information from mention, entity, and type. That's why we can create the link loss. We optimize by multinomial cross-entropy over the set of candidate entities, these candidates that are generated by this algorithm, and to find the correct entity. So, but there are hierarchies. Our standard bilinear model scores a hypernym link between two C1 and C2. For example, C1 is the child of C2. There could be other child as well. So we want to leverage these. We want to leverage these hierarchies. And there is another article which handles this much more beautifully and much more powerful. I will explain in a different lecture. But for example, for complex bilinear, it's not just real; it's complex values. So because it's a complex number, it has real part and imaginary part, and so we learn that as well. So now we can learn by hierarchies, and sigma here is just the logistic sigmoid over that score that we have obtained. For example, this is an example of prediction from med mentions. Each example shows a sentence with entity mention span in bold. For example, the hierarchy is that we have structure, order, or structure, general epistemology.